The additive manufacturing process enables us to manufacture parts that we cannot manufacture today with normal, traditional manufacturing processes. That enables us to be more ingenious in terms of how we design our turbine blades, how we cool them and how we life them.
Turbine blades has always been, I feel like, a vision. It's a real target. It's the most challenging area of the turbine. So if you can print a turbine blade, you can pretty much print anything. And we've proven over the last couple of weeks now that we have been able to print a turbine blade and test it in an industrial gas turbine engine.
In Lincoln, we're testing a 3D printed plate, and we believe this is special because it's the first time anywhere in the world this has been tested at full load conditions in a gas turbine. We test these blades very quickly. In 1 hour, we run the engine at full load. We put a probe in here to measure the material temperatures, which tell us how long these blades will last in a turbine.
Now, the turbine blade itself is this particular blade. Now, this is the high pressure turbine blade of a 13 megawatt SGT 400. Typically, we have to do all of the design, analysis, the aerodynamics, the work in terms of heat transfer on this blade 2 years before we can actually then understand in an engine how it's actually going to perform. What additive manufacture does, and this is the additive manufacture blade that we've actually tested in this engine, this gives us the ability to cut that lead time down from 2 years down to 2 months.
It allows us to create new designs, to get more efficient engines, more efficient designs into our turbines, tested and then onto ultimately our customers.
We will see quicker development times.
You don't need this very expensive tooling in order to make your products. So that makes additive manufacturing perfect for design modifications. You'll get there much quicker.
The basic process starts with receiving the model from the customer. We'll then take that model and slice it into very thin layers and export it to the machine. The machine then builds it up in a very thin layers, 20 microns, using a laser to melt all of the metal powder together to create the final product. Although we've been developing the technology for 10 years, we're still very much at the beginning of the journey of what this technology is capable of. To a certain extent, if you can design it, we can make it.
None of this would have happened without the tremendously close collaboration between a large number of Siemens units. It really is ingenuity for life to enable us to satisfy all of our customer needs.